Good afternoon and welcome to today's webinar called 3 Ways Tiers Can Save 25% in Production Costs. The webinar is presented by Schuler North America and hosted by MetalForming magazine. My name is Brad Kubin. I'm the editorial director of MetalForming at PMA, and I'm pleased to serve as your moderator for today's session. Before we get started, just a few notes about today's GoToMeeting session. It is being recorded for archiving, and the recorded event will be posted to our website within the next few days. So we'll let you know via email when that recorded archived webinar is available for viewing online. Also, all participants in the meeting are in listen-only mode, which means that the speaker and other listeners will not be able to hear any audio from your site during the program. However, you'll be able to communicate with us throughout the program by submitting any questions, comments, or issues using that question box, which is located on the right-hand control panel on your GoTo screen. So you'll simply type your question to an organizer as selected from that drop-down menu, and then you'll use that same question panel to ask questions of our speaker at the end of the presentation. So now it's time to begin today's webinar, which discusses new ways that metal stampers can reduce downtime and increase performance by leveraging the press shop of the future, which comprises technologies that promise to maximize overall equipment effectiveness. Our speaker today is Gurinder Singh, Sales Manager for Schuler North America in Canton, Michigan. So please welcome Gurinder.
Thank you, Brad. Greetings to everybody. As Brad said, my name is Gurinder Singh, and I'm the sales manager here at Schuler Canton in Michigan. In today's topic, as you all know, we would be concentrating on 3 ways tiers can save up to 25% in production costs. Of course, this calls for many other parameters as well, but this is all the estimated, and plus we have done the case studies for the presses that we have already supplied to the customer base around the world. So let me take you through this presentation. We have tried to, it's always a difficult situation wherein, I mean, you're presenting a technical paper, you're fitting a dictionary into an hour to explain it to the people. So let's go forward and let's see. Yep. So starting with, we will come to the subject TRITON, what Schuler is now building up a concept for the presses. It's an industry-wide challenges that we all are facing as stampers, like digitalization in production, flexibility in whatever we are manufacturing today. These can be the large-scale products or mass production, or the companies like tier 0.5, tier 1 to tier 3, those who want small size batches. Worldwide requirements. Most of the companies today are having footprints around the world. Some people are based out of Asia, some people are based out of Europe and also America. So they have got multiple locations. So we also try to fulfill the worldwide requirements as well. Sustainability, a big question in the stamping and cutting, of course, with the OEMs as well as with forgers, with tier 1 to 3 customers, minting presses, or whatever presses you would like to call it as. So energy saving is one of a big question that most of the press manufacturers are catering to worldwide. Then, of course, everywhere when you travel is a big question of retention of the skilled laborers or workers as well. TRITON, when it started in Schuler, was a press concept for the future. When we talk about concept, it's a modular design. And when we talk about a modularity, we talk about certain presses to group them together so that people can manufacture, source them properly, and then probably if you've got different footprints around the world, you can have similar presses And when connecting them through IIoT, you can see the production managers worldwide can see these presses as to what's happening on my press, which is operating in Europe for this example. So TRITON is a modular concept with unified components. So I will come to those examples when we are going forward in the presentation. We have got conventional driven. When I say conventional, these are flywheel driven presses. And we also have the servo. So we manufacture these presses like monoblock presses, the small tonnage presses, as well as the tie rods. When I talk about the monoblock and the tie rod, the stiffness is a big concern for the manufacturers, like press manufacturers like us. We can deliver the presses like a 2-point press or a 4-point press. Twin servo is one of the other type of press which Schuler really boasts upon. Why? Because it has got 2 servo motors, which is purely based into the pit of the foundation. So it's a bottom driven press. It has got its own pros and cons, which we will be discussing when I take you forward through this presentation. TRITON presses are industry 4.0 ready. So no matter what you order, these are absolutely ready to meet the next generation of digitalization, which is coming into picture now. So we've gone through the conventional and the servo, 2-point, 4-point, and the tie rod presses, enhanced with digital solutions. So like I mentioned, this can be individually expandable. Sustainability, like we are putting on a lot of components which are energy savers. High spare part availability, like I told you earlier, most of these presses, if you're talking about a 2,500 ton eccentric or a link driven press that is comes under the flywheel driven versus a servo, you will be having a lot many unified components in this. And plus, yes, since Schuler is into the turnkey solutions, we also give the automation like the transfer feeder, destackers, coil lines, and so on. So when I was talking about the modular design, we all know that modularity is a principle. Now, when I talk about a principle, immediate example comes of a car. So if I want to buy a car and I have got less money in my pocket, I can still go and buy the basic model and then upgrade it later on with whatever modular things are available. For example, a 7-inch screen display on my car. So with TRITON, you get increased output because most of them are built to that extent, like servo presses, and more availability with putting on different automations as well as digitalization. We also have faster setup with offline simulation programs, enhanced flexibility for the dies and the process. Of course, you can do certain things offline and then bring it when the press is ready for production. Reduce training time for new workers. Most of our softwares or the programs which come with the TRITON presses are intuitive. It gives you enhanced things and they are graphic driven, plus the videos. It helps the customers, workers pretty fast to come onto a level which is required by the company. Increased organizational efficiency, like you can have a lot of things, like you can have the same control, visualization, depending on the different market situation where you are in. So new processes, digitalization, increased output availability, and advanced press diagnostics to OEE. This is the buzzword now. Each and every organization is trying to achieve OEE to the maximum. Why? Because they want to make more parts per shift, per hour, or per day, or annually as well. So 3 ways a company, or we can save up to 25% in production costs. we have curated 3 main topics for you all. It talks about technology, digitalization, and operations. When I talk about putting it 100%, let's take it a theoretical example. So technology contributes close to around 70% of the entire cost. Digitalization, close to around 20%, and operations being at around 10%. Now, most of the companies, they have good amount of skilled labor. So they can do away with like simulation softwares if they're already doing it. So you can do away with those 10%. But when I'm talking about technology, it has subdivisions to it, like rigidity of the press, performance of the press, how much energy saving I'm doing on each part, each component, family of parts, higher efficient motors that I'm using, efficiency of these motors, how much I am minimizing the higher off-center loads, transfer with anti-vibrational damping, which is Schuler technology again, which we will see in one of the videos as well. And going forward on technology, we have got for TRITON presses, which we have already seen with and without servo. So the servo comprises of 3 main types, that is monoblock servo, tie rod servo, as well as twin servo, which we call it as a TST. In conventional design, we've got eccentric presses and link driven presses. With the TST design, why I'm emphasizing it's a bottom driven press. The pressure points for these particular presses are outside the bed surfaces. So with the standard design, they are obviously, we all know that they are inside. And depending on the depth of the bed and the distance to the pressure points, these presses have it at right angles. So when you have it, it has much more rigidity as if you define it with a conventional press. Servo presses. These are quite efficient, directly attached to the main shaft or the drive shaft without the reduction gears. You get high optimum torque even at slow speeds. You have got water cooling, which was earlier like an air cooling, or probably in the flywheel presses, it was much more difficult. You only had the sinusoidal waves that you could have similar, like the TDC to the BDC, it would be constant. But with the servo presses, you can control how your slide behaves from the TDC to the BDC. I joke around with a couple of people when I meet my customers. So like in humans, you've got 2 main dates. It's the birth date and your death date. And rest everybody around you is interested in what is happening between these 2 dates. So my joke for the presses is everybody is interested in what is happening between the TDC and the BDC. We all are interested in this zone only. So that's why if we are with the servo presses, we will be much more interested because we get more time for our transfer, for our lubrication if we are performing anything, part transfer if there is a rollover in between. And we can take much more into consideration if we are doing it with a servo press. Here is an example of the same. So on the left-hand side, you've got a TML, which is a link-driven 4-point 1100 ton with a table size of 5 by 2.2 meters. When I'm talking about tonnage, I'm referring to metrics, and these are not US tons. So the total consumption for this particular press was around 11.04 kilowatts per hour. So let us consider this as 100% of the energy that you were utilizing on this. If you see on the right-hand side on the center graph, the total consumption using the same 4-point servo-driven press was 8.18. So this is close to around 26% less energy which we did. And the component was similar to both these presses. And we were running at around 14 parts per minute for the continuous run. We measured it with a, say, 4-quadrant counter EVU measuring device, and the measuring device time, was close to around 15 minutes. So you can see when you're utilizing a servo press, approximately the energy levels around 26% for the consumption. Energy efficiency. Sustainability is much more important today as it was earlier. So Schuler is bearing down all relevant parameters in plant process technology, whether it is a matter of saving electrical energy, cooling water, air, space requirement, machine configuration, process optimization, and many more. So TRITON presses use the energy efficient components, like I mentioned earlier. It is standard. Most of these which are shown on the slide are standard, except the noise absorbing cabin or the sound enclosure, you can say. Most of the things which are much more common in the European side for less energy consumptions are illumination with LEDs. Main drive motors using a torque motor with servo driven can be up to around 96% of efficiency. Hydraulics, powertrain, of course, with optimized mass inertia, fewer moving mass that you have with the gears, and you have got less friction in the crown. One of the packages that we talk about is energy monitoring. I have been emphasizing much on energy because this is what most of the companies in the Asian market and European market are much more concerned about. Any which ways, it is also coming to the US as well. So energy consumption, when you take a package like an EcoForm Plus package from Schuler, energy consumption you can monitor per part, total energy consumption of the complete line. This gives you a capability of immediately seeing as to how much energy consumption is done by your machine. You can also quickly and easily identify deviations because you've got historical data on this. Energy monitoring system creates the highest level of energy transparency. So the production manager might come up with a couple of questions like what stroke rate is most efficient? How much energy is consumed for one part, or what part is causing a problem for the energy? How much energy was consumed during each shift, and so on. We also have got options package like the energy efficiency for process monitoring. For the envelope curve, you can have two limit curves, like the upper limit as well as the lower limit, and you can define how your target value looks like. Whenever your tolerance band is crossed, the press shuts down when the set parameters, of course, are exceeded. This is what I was talking about, the option for process monitoring. We also have condition monitoring. So you can measure the temperature of the engine bearing or the motor bearings, drive shafts, eccentric shafts, servo brakes, etc. And of course, you can have the energy efficient certificates if your company is already under ISO 14955 or ISO 50001, which are required for the energy management. And on the right hand side, you can see the screen which shows a realistic snapshot from our presses when how much time the press was under production, how much time did it take for die setup, what were the errors and how much time it was under the error. And of course, when you have no data for those dies. One more quick example over here for the servo direct technology when I'm talking about a powertrain or high efficiency is the comparison of the curves which I have over here. This is a 6,300 kilonewton press. So we've got a couple of graphs. You can see the dark blue shows for the full stroke load run, the light blue which has full stroke but in idle run, and the best which we consider is the pendulum stroke. Now, we all know that the higher stroke rate will definitely result in higher consumption of energy. Power consumption and component specific energy consumption in the pendulum stroke is much, much lower than the full stroke, especially at the high stroke rates. So you can see on the left bar chart that it's the average electrical energy consumption kilowatt for all the three units that I specified: full stroke, idle run, as well as pendulum. The pendulum stroke has the minimum energy consumption as compared to the stroke rate it is performing at. And when you're talking about a specific energy consumption, on the right hand side, you can see it is still lower with, if you compare it with the full stroke, or even if the full stroke under the idle run. Low mass inertia, high force compensation. So most of our presses, or all our presses, are using double helical gears, or we also call it like a herringbone gears. So these are transmitting power between the parallel shafts. Herringbone gears were developed to overcome the disadvantage of the high end thrust that was present with the single helical gears. So since it has got the opposite helix angle and the gear cuts according to it, with a very narrow gap in between, allows them to ensure axial thrust load are negated. These are self-centering gears, and that's the reason you don't have any external transverse forces. These are casted wheels and in one piece. That is where they give you better dampening properties, higher stiffness of the drivetrain, and thus also the crown leads to the direct power transmission in long service life. Under the technology, it's again one more point which most of the customers are worried about, is the high off-center load capacity. With the Schuler presses, we have higher center load and permissible forces below the curve is completely usable. When I say completely usable, it's 100% of the press capacity. The extremely high tilting resistance combined with the reduction in deflection leads to an improved quality of the parts. It reduces stresses on the dies, so you don't have much die work, repair, and the die life is a little bit more than the average dies that you are using on a conventional presses. For example, the pressure points on the twin servo, like I told earlier, are on the outer side. So you get much more, say, off-center load, minimizing the off-center load capacity on a TST press. Most of the presses generally have around 67% of the total area as the power on a specific area. So generally, these are like 2/3 of the length multiplied by the width. In Schuler presses, it is 2/3 of the length and 2/3 of the width. So it's close to roughly around 40 to 45% of the total area, which means that you have more power possible on the same area when you're operating with a Schuler press. Pressure points. Of course, Schuler manufactures presses with 2-point as well as the 4-point pressure points. So depending on the force transmitting element, we have configurations for the pressure points. When an off-center load is exerted by the die on the slide we all know that a multi-point press is better able to adapt or counter the resulting tilting movement. So you've got large adjustment ranges for maximum flexibility. In our cases, our presses have around 2 inches of overload, that is close to around 50 millimeters overload travel to protect the press as well as the dies. Detects the loads higher than the nominal and shuts down the press movement. So there is an oil chamber which releases during the process given the time for the slide to break. Slide guiding. Better the slide guiding, lesser tilting you have got on the press. So 2-point presses are with 8-sided roller guides. These are backlash free, pre-tensioned. We all know that roller guides are similar to ball guides, but roller guides have got a line, say a line contact with the slide and the Gibbs capacity as compared to the equivalent size of a ball version. So roller guides provide greater area of contact as compared to the ball guides. On 4-point presses, we have got, say, suitable for large cross forces. The slide guiding is guided along the entire stroke of the guides. Schuler transfer system with active vibration dampening, or AVD. This is also a modular system that Schuler has developed and has been used by so many customers worldwide. It's an asynchronous movement, profiles, selectable clamping boxes, which you can have positions in the entry or the exit of, say, freely programmable access with perfectly synchronized movements, provides you with the best adaptability for all the components. 4-point and the 6-point support offer maximum rigidity of the rail and the safe transport of the components, even if you're operating it at a maximum speeds. So you can get, or if you're overlapping most of the automation with the transfer system, you can have a high output of close to around 10 to 15%. Also at higher velocities and acceleration with less vibration. I've got a beautiful video for you all over here, which explains how exactly this works. So this particular press, for example, is operating at around 34 parts per minute. And you can see the vibration which is happening when we have put the AVD off. As soon as you switch it on, within a couple of seconds, you can see the movement is completely gone to stabilized. So the x-axis is close to around 800 millimeters, the y is 200, and z, the lift is close to around 50. And plus, the electronic overload protection of the transfer system guarantees that a safe shutdown and access do not have to be recalibrated again. Like I mentioned earlier, Schuler is always present as turnkey solution provider from feeding to removing. So Schuler Complete Line, you can have one contact or the main project manager. Output optimized, you've got same visualization, the HMIs for almost identical for all the presses throughout. So it is so intuitive so that the workers as well as the on-site managers have very easily operability of the HMIs and the visualization. Going on to the next topic is the digitalization. So we're talking about the overall equipment effectiveness. This is a production monitoring which we have on most of our presses. We all know that overall equipment effectiveness is like a standard for measuring the manufacturing practices. Now, in a theoretical, if we multiply all the factors together and want to propose this, an OEE of 100% means you're manufacturing only good parts as fast as possible, say with no stop time. Oops, I'm sorry. Production monitoring, it's a hardware. This hardware allows the machine to communicate with Schuler Data Loft. It's our core computing center for managing, processing, and visualizing machine, as well as process related data. The addition to data, one can also easily find documentation for maintenance instructions, operating instructions, and so on. So one can have through this on a separate channel, which we of course hook it through your system's remote service connection, current as well as historical production data, and is available whenever you need it. Comparison of the system productivity over periods of time, production shifts, and different die sets. Identification of the trends in production stroke rates, say scheduled and unscheduled downtime, and system utilization. So as an example, you can see over here is our MSD press, which is doing, say it's under setup. You can see it has gone around 35 minutes under setup mode. Total components that you're going to manufacture is 25,000. You're already at 24,000. Another screenshot which talks about how much time the machine was under production for each and every die, how much time it was under, say, non-performance, how much time it was under the setup mode as well. Overall equipment effectiveness can also be done with one of our camera-based monitoring system, which is VDP. It's a visual die protection. The beauty of this product is it can also be implemented or programmed onto a non-Schuler press. So it is not Schuler related. It's a separate digital item or the camera-based monitoring system that can protect against tool damages, machine downtime, and it can save costs up to around 10%. With this camera-based system, you can detect foreign objects which are present. Of course, there are maintenance happening on the dies. Sometimes the maintenance guys can leave the spanners, or there is a missing part. There is process inspection, in-process checks, monitoring of critical die functions, and so on. So the first time when you put the VDP into it and you're about to go for a production, you make a reference image. This is called as a good status of the die. I will be multiple times, I will be going forward and backwards to these two slides because I want to show you how the anomalies work. So on the left-hand side top, the part was not taken out either by say operator or a robot. So you can see on the part on the left-hand side, there is a glove left by the maintenance guy on the die. There is a spanner, and also there is a pin which fell loose on the right-hand side. So this is like the actual triggered status. And every time there is an anomaly, it sends signals to your press and the press shuts down or stops to that minute immediately. I've got a video for this, which I'm going to play for you. So with VDP, you can put up to 8 monitoring functions on one particular die. So you can select the camera, the time, the image area, and specify the limit value for that particular critical deviation that you want. So the cameras then start monitoring the press when it is in function. And whenever an anomaly or something happens which you have reported it, it will immediately tell you what exactly the anomaly was. You can go in, correct it, and restart the press again. So live images are compared to the reference images at defined times and checked for the critical deviations that you have. So let's move on to the next topic, that is operations. Under the operations, Schuler has got a couple of online as well as offline programming, like the Optimizer Pro. The Optimizer Pro is a basic curve generator. So basic, I mean, you can program everything offline and then push it on to the Smart Assist, which helps records die-specific parameters for the press, the transfer setup, and plus you can do the optimization. With the Optimizer Pro, the transfer angles can be calculated automatically. Movement profiles of the slide can be designed freely in regard to the stroke height, form, as well as in speeds. So the Smart Assist is a software that helps to record the die-specific parameters for setting up and optimizing the press as well as the transfer. And it takes, like I mentioned, it takes all the calculations that you have already done under the Optimizer Pro. So let me take you through one more video, which is simple and intuitive for the graphics. Like I said, for your new level workers as well, this is absolutely simple to go through. So under Smart Assist, you go to the production data, you select the Smart Assist, and you get bunch lot of options into it. So you start clicking the one which you want to optimize your particular transfer. So it will give you step-by-step information as to what exactly you to perform. So you open the slide, ensure that the position of the slide is in TDC, position the transfer at the pickup position, lift the parts by jogging it in the Z axis until the target feed movement is achieved, and register that particular target and put it into the teach function. And then once it is absolutely clear of the tolerances, it takes care. So this is also beneficial for your easy creation of the new die programs when they come in, or new part program that you're developing for the OEMs or tier 0.5. Datas are recorded directly, I mean, with the teach-in functions and the press control panel or a smart device. It is fully automatic because you're taking all the data from the Optimizer Pro. This particular Smart Assist is also retrofittable. But it all depends, because if you're having presses which are too old, then probably most of the presses, they do not have, like, for example, an Ethernet connection. So we can figure that out, but it needs too much of diving into the situation what you are currently in. DigiSim Unlimited is an offline virtual production ramp-up software. So this is an offline simulation. It can be for a prog die as well as for the transfer presses. This is an add-on to one of our, again, simulation program, which we call as Transfer Basic. It also has beautiful features like programming of additional movements if you have lifters, rotating grippers, kinematics, which are completely different what you want to do from one tool to the another. You can do like automatic, it has got the automatic collision control as well. So DigiSim has got generations of all necessary processes. It has got reliable output calculation for better pricing of the part. Die data can be prepared, optimized, and managed offline. So if you have got a new die or a new part set which you have to prove it out, you can do it offline to the absolute last level and then push it onto the press. To explain this, I've got a video. This is a simulation done on our servo press 1600 ton with a medium duty transfer system. So you can see, you can operate the press at different stroke level and see how exactly you can ramp up the production, at what speeds you're operating, whether it's 160 millimeter before the BDC or after, say, you can go up to a 240 millimeter per second. So the transfer movement is optimized with overlapping motion of different axes. And here you can see same speed forming as a conventional press. If you're operating, that would do at around 9 parts per minute. In that, we come to the end of the presentation. I hope you all were okay with whatever was shared and being a patient listening to our presentation on how you can. And just to recap quickly, we have got, like I already mentioned, these are the series that you have, like the monoblock design and the tie rod design. We have press forces from 250 to 3,200. These are all metric tons. Comes in a monoblock or a tie rod design. Comes with Optimizer Pro, shorter die setup times. TST version. Worldwide, it's unique. Why? Because it's got the servo motors in the pit. That's how you get around 30% less spring back on most of the components that you're manufacturing. It has got significantly higher off-center loads with the same press force. And of course, with the flywheel or the conventional driven presses, we've got eccentric as well as link. So eccentric drives up to, say, 1250 tons, and thereon we are into the 1600 ton up to 32. We are into link driven presses. And if we have any questions, which I can answer.
Yeah, thank you for Gurinder for that very nice presentation. Lots of good information in there, a lot to digest. So yeah, we've got about 10 minutes left for questions. If anybody in the audience would like to dive a little bit deeper into what Gurinder had to present here. I do have a question for you. I found that EcoForm functionality pretty interesting and certainly useful, I suppose, for ESG reporting, which is becoming more and more important as time goes on. And if I heard you right, so you can capture energy consumption by job number or part and report that back then to the customer, I suppose, right?
Yes.
Okay. So are you seeing that being done currently, or you can see it coming down the road with some of your customers?
Yeah, this all, I mean, whatever percentages I have been stating during my presentation, it was all a brainstorming session internally, which we did at Schuler. Also, we got the all analysis and everything done with the customers, those who are already using our servo technology or the TRITON series presses.
Fantastic, great, okay. So what more can you share with us then about the trends that you're seeing in terms of press size by force or bed size? And if you want to comment on those trends and maybe the challenges that they present to manufacturers.
Yeah, looking forward from Schuler, we are seeing a trend which is most of the tier ones, 0.5, as well as tier 1 to 3, they are moving from the conventional or the flywheel driven presses towards the servo. I don't mean to say that servo is the next, it always depends, but yes, the market is moving towards the servo technology.
Sure.
And when we are talking about bed sizes, yes, they are increasing as well. Most of the customers now are going to 7.1 up to 8 meter bed lengths as well.
Okay, very good. So in terms of the visual dot protection, I know you've had that available in North America for a short time, perhaps. I don't know, maybe you can comment on how long it's been available in North America, but how have you seen the reception in this market for VDP?
Oh yes, on VDP, the visual diode protection, we are getting huge amount of inquiries, and we have already implemented around, if I'm not mistaken, around 10 to 12 customers. And these are not only working on Schuler presses, like I emphasized during my presentation, this is also for the non-Schuler presses. So we have also sold this to the press manufacturers or the companies, those who are non-Schuler brands.
Okay. And that's fairly easily integrated into?
Integrated, yep.
Non-Schuler.
You're right.
Yep. All right, any more questions for Gurinder? We've got a couple minutes left. If not, all right. Well, again, thank you, Gurinder, for that really nicely detailed presentation on kind of the future of press functionality from Schuler. To our audience, thank you for attending the program today. We hope you found it to be valuable. And once again, an archive of the event will soon be available on our website. So when that's ready, you'll receive an email from us, and then you'll be able to review what you learned today and share it with others within your organization, should you desire. So again, thank you, Gurinder. Thank you to all our attendees and to Schuler for sponsoring today's event. Everyone, you may close your browsers now and have a great afternoon.
Thank you. Thank you, Brad.
Yep, thank you.